All right, hello everybody. Big section here, 3 variable systems. Okay, so we're going to go through a couple examples. Just a heads up I always like to give on these. You're going to find yourself making little mistakes. You're going to get crazy answers, or they're not going to check or something. It's going to be frustrating. So just be ready for that. There's really no way around it. It even happens, if you miss one negative sign, and then you do 5 more steps and then you realize something's wrong, it's going to be hard to figure out what happened. So, my advice, take your time. It's little arithmetic, adding, multiplying, negative signs, things like that. Take your time, write neatly, go slowly, and, just be extra careful. I usually try to assign problems that have nice, relatively small number, whole number answers for the most part. So if you're getting like crazy decimals or huge numbers, and it's a problem from me, it might be something wrong. Now, of course, in real life, the answers aren't always nice, but for this section, you can kind of anticipate there'll be nice numbers. So let's get into an example. I have a couple. I have a method I think is the best for these, and we'll walk through it. Here we go. All right, so the methods that we've been using, like elimination and substitution, are going to be the same ones we're going to use here. Okay, so let me number these. So this is problem 1, but I'm just going to number the equation. Let's call that equation 1, equation 2, and equation 3, because I'm going to refer back to them quite a bit. So here's the deal. We have 3 variables, x, y, and z. Okay, so you must have 3 equations. Okay, just like remember the earlier section, once we had 2 variables, we needed 2 equations in order to solve them. So if we take a look, in this case, this is kind of nice because in equation 2, there's no y variable. Okay, so my advice on these is to turn these into a system of 2 variable equations like we just did in the previous section, and then you can do this back substitution and find the third one. So some problems you're just going to have to decide where to start, but this one, since equation 2 has no y's, what I'm going to do, I'm going to get a second equation without y in it. So I'm going to eliminate y, and I'm going to do it in equations 1 and 3. Okay, and then I'm going to take this new answer that I get and then pair it up with equation 2. So let's first just write equations 1 and 3. We have negative 2x plus 3y plus 2z equals 15. And just be careful when you're writing these out, okay? Even if you write something wrong right at this step, you're going to do a whole bunch of work and then you're going to be mad at yourself that you made a typo or something. So it happens. Okay, so double check. Everything look good? All right, so if we need to eliminate y, okay? Because again, I'm going to then pair the new answer, the new equation, with equation 2. So how would we eliminate y? Okay, one of them has a positive 3y, one of them has a positive 5y. So let's try and make them opposites. So I'm going to multiply this equation by negative 5 and this equation by 3, and here's why. Okay, just kind of look ahead. Look at the middle term, the y values. On the top equation, it's going to become negative 15y when I multiply that negative 5. And in the bottom equation, it's going to become positive 15y. Those will eliminate. So let's carefully do this. So distribute the negative 5 across the top equation. It should become positive 10x minus 15y minus 10z. And then negative 5 times 15 is negative 75. Okay, now let's distribute the 3 to the bottom equation. 15x plus 15y minus 18z. And then 3 times 19 is what, 57? Yeah, okay. Okay, so now we have a system of equations where we can add these, okay? We're using elimination, right? We're going to eliminate the y variable. All right, so adding, right, straight down, 25x. The y's have eliminated. The negative 10z minus 18 more z is negative 28z. And then the negative 75, if I add 57 back to that, I'm getting negative 18. Okay, I'm going to call this equation 4. Okay, it's a true equation. It's just a variation of some of the other ones that we had. So now what my plan is, though, okay, is I have a system of equations, right? I have equations, look at equation 2. I'm going to solve the system of 2 and 4. Okay, both of those equations only have x's and z's in them. Okay, let's write that system. 2x, here's equation 2, 2x minus z equals 6. And then equation 4 that we just got in green there was 25x minus 28z equals negative 18. So I'm going to solve that like it was a little two-variable system from the previous section. Okay, I'm not even worried about anything else. I'm just solving these for now. Okay, so let's do that. Let's move on. Let's solve that system. Okay, and again, usually elimination is going to be the way to go. What I can do here is multiply. It's probably going to be easier if I just multiply the top one by negative 28. That will force the z to become positive 28z. Okay, and I chose that instead of eliminating the x, because if I eliminated the x, I would either need to multiply the 2 by a fraction, or I would have to multiply both equations by something. Okay, but eliminating z I can get away with just like this. So let's distribute that negative 28 to the top equation. So negative 56x. It's going to become plus 28z. All right, and then negative 28 times 6 is negative 168. Okay. The other equation, I'm just going to rewrite it underneath so we can do our elimination nice and organized here. Okay, we are now ready to add these equations together. Right, we're doing elimination over and over and over. So the negative 56x plus 25x is going to be negative 31x. The z's eliminate. The negative 168 minus 18 more is negative 186. And I can solve for x by dividing by negative 31. So x equals positive 6. Okay, so just watch your steps there. That's one step where people will divide and they will miss a negative sign or something, and that's going to throw everything off. Okay, so we have x equals 6 now. Okay, and again, remember, we're solving basically a two-variable system to start here, right? I'm solving this system right here. So we got x, now let's go back and find z, and then once we know 2 of the 3, then we'll be able to find the third variable. Okay, so I'm going to use the original equation 2. I'm going to substitute this in. Okay, which said, so equation 2 from the beginning, right? 2x minus z equals 6. You can use any equation as long as it only has two variables. You could use either of these right here to find z. Okay, so equation 2 said 2 times x, which is 6, minus z must equal 6. So 12 minus z equals 6. Okay, we'll pick this up here. I'm going to subtract 12 from both sides. Okay, so negative z will equal negative 6. And when we divide both sides by negative 1, z will equal 6. Okay, so x and z are both 6. Okay. Now, all we got to do is one last little step and we will find y. Okay, to find y, we can plug the x and z that we know into any of the other equations. Okay, I'm just going to go with equation 1. Okay, because equation 1, remember the original problem, equation 1 had all 3 variables, and now we know 2 of them. So equation 1 said negative 2 times x, okay, we know x is 6, plus 3 times, or y is the one we don't know, plus 2 times z, which we just found out is also 6, needs to equal 15. Okay, so that's just equation 1. And you see why I like to number these now, so we can keep track of what we're doing. When we use other equations, it's nice to have them numbered. Okay, so simplifying this, we have negative 12 plus 3y plus 2 times 6 is 12 equals 15. Okay, we simplify that, combine negative 12 and positive 12, they kind of cancel out, so we have 3y equals 15. And dividing by 3 will get us our y value, y equals 5. Okay, so we have all three answers, we circled them all. You could choose to write them as an ordered triplet, it's called, an ordered triple, because it's x, y, z. So in that order, it was x was 6, y was 5, and z was 6. Okay, or if you just have the answers individually solved for, that's totally fine as well. Okay, so a little bit of a lengthy process. Just make sure you're being extra careful. And the key here is, and it just takes a little practice, but the key is turn it into, at this step, we turn it into a system of 2 variables. Right, so I wanted to get 2 equations that had the same 2 variables. That's why from the very beginning, our very first step up here was to eliminate y and then use it with the second equation that had y already eliminated. Okay, and then once you solve that 2 variable system, you get back down here and you do back substitution. All right, so let's do one more. All right, so let's take a look at another example where we have to kind of do everything. Just because the way it's set up here, you know, looking at these 3 equations, all 3 of them have all 3 variables, right? So if I just number these, 1, 2, and 3, right, there's no real obvious way of eliminating a variable. Okay, let's see, even looking at these further, I'm going to have to do some multiplication. So here's where you just have to choose, you know, just choose a starting point. Because again, what we want to do is we want to get a 2 variable system. Okay, because we just did those, we just did a bunch of problems last section, right? So let's try and find the easiest way to get 2 equations to have the same 2 variables. And then we'll solve that and back substitute. So just kind of looking, I'm going to eliminate, let's eliminate x. Okay, and you got to pick, right? Let's eliminate x in equations 2 and 3. Okay, and I'm just looking because I can do that with one little multiplication, right? So what I'm going to do is I'm going to multiply equation, let's see what we got. We're eliminating x, right? So I would need to multiply equation 3 by 2. Okay, so original equation 2 was 2x minus 2y minus 3z equaled 9. And then the way I'm going to write this, just to keep track of what I'm doing, if I'm trying to eliminate x, I would need to go 2 times equation 3. Okay, and again, I'm just doing this to keep organized. You don't have to write everything exactly the same. But if you look at equation 3, if we multiplied it by 2, we would get negative 2x. We would get minus 8y minus 4z equals 30. Okay, and what that's going to do, that's going to allow us now to have this x get eliminated, right? We see when we add those, the x's are going to cancel out or eliminate. We'll have negative 10y minus 7z equals 39. Okay, and I'm going to name that equation 4, and what we're actually going to do, we're going to just put that aside for a minute and come back and get it later. Okay, because what I need to do is I need to get another equation which has x eliminated. So I'm going to eliminate x in a different way using, I can't use equations 2 and 3. Why don't we use equations 1 and 3? Okay, looking at equations 1 and 3, equation 1, I'm just going to rewrite negative 3x minus 5y minus 6z equals 3. Okay, now if I want to eliminate x, I would need to, and again I'm using equation 3 now, I would need to multiply it by negative 3. So I'm going to do negative 3 times equation 3. Okay, and that's going to give me positive 3x plus 12y plus 6z And let's multiply the 15 by negative 3, we get negative 45. Okay, and what that's going to allow me to do, okay, when I add these together now, I'm going to eliminate x. I have negative 5y plus 12y is 7y. The z's actually eliminate too, so that's kind of a bonus. 3 minus 45 is going to be negative 42. Let's call that equation 5. Okay, now normally what would happen is we would use equations, I'm trying to get a color to highlight here. We would normally use this equation that we just got and this one, okay, equations 4 and 5, and they would normally have the same two variables because we eliminated x both times, right? So you would then take equations 4 and 5 and kind of solve them as their own little system, using elimination again, most likely, like we did in the last problem. But what's going to happen here, this one's going to work a little quicker because our equation 5 here only has one variable in it, right? If 7y equals negative 42, we can divide both sides by 7. I can get y equals negative 6 right there. Okay, and I can start the back substitution process a little bit sooner. Okay, meaning I can now take that y value that we know and plug it into equation 4. Okay, I don't want to plug it into any of the original equations because the original equations have all three variables, right? But if you look at equation 4, it only has y and z. So since we know y, there's only one unknown variable. Okay, so let's see if we can figure out what z is. So negative 10 times negative 6 is 60, minus 7z equals 39. If we subtract 60 from both sides, that should give us negative 7z equals negative 21. Okay, and now we can just do our little division by negative 7. And we're dividing a negative by a negative, so z will equal positive 3. Okay, now we know y and z. Now's where we would go back to one of the original equations, okay, because we need to get x. So I can use any of the original equations. I'll just use equation 2 because it kind of has the most positive numbers and small numbers. But any original equation would work. So let's rewrite equation 2 as 2x minus 2 times y, which we know is negative 6, minus 3 times z, which we just found out is 3. That has to equal 9. And we're just going to go and solve this for x. And then we should be good to go. So 2x minus 2 times negative 6 is going to be like minus negative 12, which is like plus 12. Minus 3 times 3, which is 9. Okay, so we have 2x plus 12 minus 9 equals 9. I'll combine the plus 12 and the minus 9 to become a plus 3. And now we can just subtract 3 from both sides. 2x equals 6, and x must equal 3. Okay, so we solved our system. Final solution is going to be in order. X, y, z was 3, negative 6, 3. Okay, but again, on these, your process is going to be, and this is how you're going to solve all these. This is my advice. Do what we did up top here, okay, where you first get yourself a two-variable system. Figure out what you want to eliminate. Find something that's easy to eliminate. Okay, if something's real easy, you don't have to multiply, start with that. Get a fourth equation. Then the key is, the next step is to eliminate the same variable that you eliminated the first time using a different pair of equations. Okay, then you will get, if you see equations 4 and 5, the highlighted ones, they should be only in the same two variables, which you can then solve using elimination to get those two, and then back substitute. Okay, so a little bit tricky on these. I want you guys to try them out. I'm just going to give you a real brief assignment, 1 or 2 problems, and then we'll continue going over and continue practicing. Okay, but be real careful again with your negatives. And I know these can give you a headache. I've seen it. you'll get your head spinning and get mad and frustrated. And sometimes you just got to start clean, start over. They are doable, and it just takes a little time. All right.